you feel like you have all these innovative ideas for web apps you want to build, but that you don't have the time to learn how to set up all the required infrastructure? Are you feeling like you want to innovate rapidly, but that you're blocked by manual and inefficient rollouts? If this sounds like you, then today is your lucky day. I'm Julia from the Firebase team, and I'm here to introduce you to Firebase App Hosting, the next generation of serverless web hosting with Google. We know how important it is to be able to ship apps quickly and easily at global scale, so you can innovate rapidly and grow your app's engagement worldwide. We also know that many of you are using modern, full-stack JavaScript frameworks like Angular and Next.js. These full-stack frameworks empower you to strategically leverage the benefits of server-side rendering, such as improved SEO and faster initial load times, with the ease and familiarity of the technologies we use to build front ends. With the demands of the modern web, you need more than just a CDN to run your web app. You need a backend. And with these full-stack frameworks blurring the lines between front-end and back-end code, figuring out what infrastructure is needed and when it's needed can be a headache.
Hey, speaking of deploying modern full-stack apps to Firebase, Angular developers have been able to deploy their apps with ng-deploy, but the full-stack experience hasn't been the smoothest. Developers have had to resort to workarounds to use things like Angular support for server-side rendering and hydration. Julia, there has to be a better way, right?
Yes, Mark, there is a better way. Meet your new best friend, Firebase App Hosting. Firebase App Hosting is the new home for full-stack Angular and Next.js apps on Google. App Hosting is a framework-aware, serverless web hosting product that automatically sets up the infrastructure needed to build and run your full-stack web app based on what it detects in your source code. App Hosting streamlines deployments from GitHub to Google Cloud, automatically building static assets in Cloud Build, deploying dynamic content to Cloud Run, and serving cached content on Cloud CDN. You push your changes to GitHub, and App Hosting figures out the rest. Here to tell you more about how we got here is my colleague Thomas from the Firebase team.
Thanks, Julia. Firebase has always loved web developers. We took pains to make sure our real-time database worked for any browser, even without WebSockets. We launched Firebase Hosting 10 years ago to be a one-stop shop for web developers. But a lot has changed in the last 10 years. Firebase was acquired by Google, and suddenly our opportunities and our customers changed. Customers wanted to see Firebase and cloud work better together, so we did what we could to unite the simplicity of Firebase and the power of cloud. Over the years, we've grown our original hosting product organically. We added the ability to redirect traffic to Cloud Functions in 2017 or Cloud Run in 2019, so that developers had a place for trusted operations and the ability to connect their site with the rest of their cloud backend. In 2020, we launched preview channels and a GitHub action to improve the development process. In 2022, we started globally replicating static assets to improve CDN cache misperformance and launched our first web frameworks experiment to embrace the many advancements in web development. Last year, we launched support for full-stack previews and rollbacks. Eventually, however, we became constrained by 10-year-old abstractions and infrastructure. Enterprise customers cannot use our third-party CDN. Dynamic content is separately managed from static content. The web frameworks experiment smooths this over, but a tooling-based approach has limitations. It was time to take our lessons and partner with the rest of Google to re-envision what a white-glove developer experience could be for shipping modern, full-stack web apps. And now I'll hand it back to Julia to show you our reimagined, modern, full-stack web developer experience firsthand.
Thanks, Thomas. Let's say I'm a web developer and I want to build a new Next.js app. I want to start by creating and deploying a simple Hello World app. I'll add more features and services into the app once I have it up and running. I'm just going to download some boilerplate source code rather than building something from scratch because I want a prototype up and running as quickly as possible. Fortunately, I can do this with a single npm command, npm init next on Firebase. I already have the source code in a GitHub repository, so now it's time to get this app on the internet. It's time to deploy with Firebase App Hosting. In the Firebase console, select App Hosting from the left nav. Then click Get Started. From here, I can connect to GitHub, which authorizes and installs the Firebase GitHub app on my GitHub account. I can install it on a personal account or on an organization. Now I see a list of repositories that Firebase has access to. This connection between Firebase and GitHub is stored securely in Google Cloud's Developer Connect. I'm going to import the Next on Firebase repository. That's the one with my boilerplate app. The next step is choosing the live branch. This is the GitHub branch that's served at my website's live URL. I want rollouts to happen automatically whenever I merge changes into the main branch. So I'm going to set the live branch to main and enable automatic rollouts. The last step is naming my app hosting backend. This is the collection of cloud services that app hosting spins up to run my web app. I'll name it Next on Firebase and click Deploy. In just a few clicks, and without leaving the Firebase console, I have a whole backend set up in Google Cloud with continuous deployment turned on for my repository's main branch. The rollout finished. I've got a live site. Let me check it out by clicking on the domain. All right, we have a Next.js app up and running in production. This Hello World sample app is cool, but to be honest, I'm not loving the color. Let's brighten things up and change the background. To make this change, you could use any editor or IDE. Personally, I like staying in the browser, so I'm going to use Project IDX, which is Google's web-based workspace for full-stack app development. Here's where the dark theme is applied. Now, to roll this change out to production, I just need to commit and push the change to GitHub. And I can do that directly from my IDX workstation. Select the branch icon to open the source control pane. Click the plus sign to stage the change, write a commit message, commit the change, and push it. Now in the Firebase console, I see that a new rollout has been kicked off. And look, the rollout finished. Let's refresh the web app. Boom, it's brighter. That's more like it. I just made a change to my app and rolled it out to production without leaving the web browser. That's pretty sweet. All right, let's go back to the app hosting dashboard. I want to give you a quick UI tour. The dashboard is where you can watch rollouts go live and access all the most important information about your app in one place. You've got information about the current release front and center, so you can easily find out which Git commit is being served and get some helpful context about what the change was and who made it. You can also access request logs and usage metrics for the current release to monitor your app's health and traffic. Then you have your rollout history. A rollout is a two-step process: build and deploy. During the build step, we generate your web app static assets and create a container image for Cloud Run. Then we deploy the app by spinning up a Cloud Run revision with the container image we just built and activating traffic. So each rollout is associated with a Cloud build job and a Cloud Run revision. Why am I telling you this? Well, we've heard from developers that while serverless architecture is amazing in many ways, one thing that can be challenging is finding out where something went wrong. If you don't have visibility into your backend services, it can be tricky to debug unexpected behavior. But that's where app hosting is different. You can inspect the Cloud build job and Cloud Run revision to find out what's happening behind the scenes for each rollout. Let me show you. All right, I'm back in the app hosting dashboard, and I want to know more about where my app is running and how it's being run. I can dig into the Cloud Run configuration used by this specific version of my web app by clicking these 3 dots and selecting View Cloud Run Revision. Now I'm in the revision details page in the Cloud console, where I can see the runtime configuration that was used for this version of my app. I see that by default, CPU boost is on to improve cold starts, and minimum instances is set to 0 by default, meaning it scales to 0 when idle, which is great for keeping costs low. I can also see the default concurrency and CPU and memory limits, which I can customize in a config file called apphosting.yaml. I can also view details about my build environment by clicking on the build ID, which brings me to the build details page in Cloud Build. These are some nice detailed build logs. I have a feeling these will come in handy later. But for now, I'll pass it back to Thomas to tell you more about how we built this exciting new product and the types of features we prioritized for this early preview of Firebase App Hosting.
Thanks, Julia, for the great demo. To recap what we've just seen, Julia created a Next plus Firebase app with npm init next-on-firebase. She created a new backend with Firebase App Hosting and connected it to her GitHub repository using the brand new Firebase GitHub app. New rollouts were created on pushes to main, and their status was linked back to github.com. A Google Cloud build job leveraged our open source build packs and detected her Next.js code and built a container ideal for serving on Firebase App Hosting. We loaded her container into a Cloud Run service and served it behind Google Cloud Load Balancer and Google Cloud CDN. Julia was able to understand what was happening in her backend with direct access to Cloud build logs and the Cloud Run dashboard. Now, Julia hasn't set up a custom domain yet, so she's using the default domain we provided. When she uses a custom domain, its certificate management is automatic and at 0 charge. Let's take a look at the founding principles that drove these features. App hosting is not a drop-in replacement for our original hosting product. It fills a specific gap. Rather than starting with the things that the original Firebase hosting excels at already, we've focused on the features that would differentiate our experience. We've optimized for full-stack web apps that require a backend. Here are a few ways we've designed app hosting to support modern, server-rendered frameworks end-to-end and follow the best practices for enterprise-ready applications. Firebase App Hosting is full stack. Firebase App Hosting doesn't just support redirecting traffic to your backend, it manages your backend for you. We've standardized on Google Cloud Run, Google's flagship serverless platform. With Cloud Run, your backend automatically scales up with additional traffic and scales down to 0 when idle to save you money. Because Firebase App Hosting owns your primary run service, we can control it much more easily, delivering a more seamless experience with fewer edge cases. Because we've bypassed the Cloud Functions extraction over Run, we are able to expose Cloud Run's features in Firebase App Hosting faster. The first of these features is the new service level min instances for Cloud Run. With this, you can reserve capacity that should always be available in your backend. As you perform a new rollout, service level min instances will rotate those reserved instances to new revisions. Firebase App Hosting is framework aware. All of the lessons we learned in the Web Framework experiment have gone into the development of Firebase App Hosting. Firebase App Hosting is the graduation of web frameworks from an experiment into an official product. Our flagship frameworks are Angular and Next.js, with a fallback to any server-rendered Node app that has a build and serve command. The Angular team has collaborated with us to release new versions of Angular specifically designed to support our build process. And Vercel has independently improved Next.js with abstractions for platform-level features. This means you'll see Firebase expose more and more features of these frameworks with a simpler and thus more reliable foundation. As we add features to Firebase App Hosting, such as redirect and header overrides, you'll be able to configure them natively as your web framework defines them. Our new pipeline is built on Google's open source collection of cloud-native build packs, which means all of Google and you can collaborate to improve framework-specific optimizations across Firebase App Hosting, Google App Engine, Google Cloud Functions, and Google Cloud Run. Firebase App Hosting is Git-centric. Firebase App Hosting was designed around Git-centric CI/CD. After installing the Firebase app, deploying is as easy as git push. You can even be a Firebase App Hosting user without ever downloading the Firebase CLI. When a new commit is detected, we annotate it with a GitHub check so you can see the status of your build and rollout in line. When looking at your rollout history in the Firebase console, you can track each version of your website to the exact commit it was built with. When Firebase App Hosting notices a new commit that matches your rollout policy, we will build your application using Google Cloud Build. This means that static site generation has access to your backend and can depend on secrets or infrastructure that your developers may not have direct access to. Our integrations with Google Cloud Build ensures your local machine's quirks don't ship to production and makes connecting to your existing backend services trivial. This platform will pave the way for a future integration with binary authorization, allowing administrators to guarantee that only reviewed code ever makes it into production. Firebase App Hosting is built on modern architecture. Best practices in the industry have changed over the last 10 years. The original Firebase hosting is a single shard. One service handles your uploads, and one CDN fronts your traffic. A single failure can hypothetically cause a global outage across all customers. For app hosting, we've partnered with multiple teams at Google to design a fully regionalized service. While your traffic is still served across the globe, the entire infrastructure of Firebase App Hosting is isolated based on your backend's region. A catastrophic failure in US Central 1 would not affect customers in Europe West 1. Within a region, we also divide our customers across multiple instances of Google Cloud Load Balancer and Google Cloud CDN. This means that a catastrophic update to Google Cloud Load Balancer will not affect all users within that region. Now that we've moved the CI and build process into the cloud, the Firebase team has more fine-grained control over updates. You will never again miss out on features because you used an old version of the CLI. These are the founding principles of Firebase App Hosting's design: full stack, framework aware, and Git-centric on modern infrastructure. These principles enable us to embrace power users while staying focused on the ease of use that brought you to Firebase in the first place. App hosting is Firebase easy and enterprise ready. App hosting makes it easy to go from zero to having a production app up and running in minutes, while future-proofing your app for success. Firstly, app hosting automatically scales your backend infrastructure up and down with demand, ensuring your app's performance isn't compromised when you get a huge influx of users overnight. What's more, as your business grows and your app evolves, your hosting needs may change. All of a sudden, you want less abstraction. You want to customize those underlying services to meet your new business requirements. With app hosting, you have visibility into the underlying Google Cloud services installed in your project, empowering you to understand what's happening behind the scenes and tailor those configurations to your evolving needs. Another way app hosting scales with you from startup to enterprise is that it's powered by reliable, secure Google Cloud products you trust. Things that weren't your top priority when you got started, but really are very important, like security and compliance, will become more of a concern as your business grows. App hosting supports this natural evolution of priorities. App hosting is built on a trustworthy Google Cloud foundation and enables you to ensure your app adheres to Google's security and compliance standards from the very start. And because app hosting is powered by Google Cloud, it will be governed by the Google Cloud Platform Terms of Service once the product becomes generally available. I'll now pass it back to Julia to show you firsthand how you can take advantage of app hosting's scalability, flexibility, and security in your app.
Thanks, Thomas. Let's show developers how Firebase easy and enterprise-ready app hosting really is by leveling up our demo from a boilerplate app to a full-featured app that uses generative AI. This app is called Friendly Eats. It's a Next.js restaurant review app that uses the Gemini API to summarize reviews. Friendly Eats uses Firebase authentication, Cloud Firestore, and cloud storage. You can download the source code for Friendly Eats from our code lab. Friendly Eats uses a combination of client and server-side rendering. While all the pages are initially rendered on the server, the components that need live Firestore data or auth state are client components. For example, this page.js file is a server component responsible for the main page, but the restaurant listings are rendered on the client, denoted by this use client directive. This app also uses streaming to improve initial load times. Streaming means that parts of your page will load as they're ready, rather than your page needing to wait for all components to be ready to load. This restaurant details page is a great use case for streaming. It contains restaurant metadata, ratings, and review summaries. And these components use different data sources, which means they may take different amounts of time to load. You don't want users to have to wait for everything to be ready before seeing any page updates. Streaming is essential for generative AI functionality that might involve long-running operations. You don't want the whole page to hang while the Gemini API works to summarize reviews. Lucky for you, app hosting supports request streaming end-to-end, ensuring your app maintains fast load times even as you add more and more generative AI features. So this app is truly full stack. It renders some stuff on the client and some stuff on the server, but that's no problem for our new full stack hosting solution. App hosting will know what to do. But before we deploy, we need to get an API key from Google AI Studio in order to use the Gemini API in our app. Visit aistudio.google.com/app/API key. Click Create API Key and copy the key to your clipboard. But what do you do with this API key? API keys are sensitive information. You really shouldn't check them into source. What you need to do is store the API key as a secret in Cloud Secret Manager, and then create an environment variable that references the secret. Cloud Secret Manager offers a ton of awesome security features, like versioning and rotation. You can also manage access control at the secret level, so you don't have to share sensitive API keys with everyone who has access to your project. Fortunately, app hosting makes it easy to create a secret using the Firebase CLI. you don't even need to go to the Google Cloud Console. Let me show you. Open your terminal and make sure you have the latest version of the Firebase CLI installed. Run the app hosting secret set command, followed by what you want to name your secret. When prompted, paste the Google API key copied to your clipboard. Then, grant your app hosting backend service account access to this secret. Next up is adding the secret binding to apphosting.yaml. Apphosting.yaml is a config file that holds environment variables, secret bindings, and runtime settings for your backend. It gets checked into source control. If creating and editing a config file sounds like too much work, don't worry, because app hosting will actually just do it all for you. After creating the secret in the CLI, app hosting asks if you want to add the secret to apphosting.yaml, offering a smart default environment variable name based on what you named your secret. You now have a secret in Cloud Secret Manager, and the secret's name is Google API key, and the API key you got from Google AI Studio is stored as a version of that secret. And in apphosting.yaml, you have an environment variable that references the secret. You can now safely check this file into source code without exposing your API key. The last step is accessing the Google API key environment variable in your app's code. Now, remember that versioning feature I mentioned with Cloud Secret Manager? You can create multiple versions of a secret. This helps you rotate secrets smoothly and makes it easy to roll back to a previous secret version if needed. Versioning also gives you a nice audit trail. It gives you a clear history of changes to secrets. If you wanted to create a new version of the Google API key secret, you can use the app hosting secret set command again. This time, the Google API key secret already exists. So instead of creating a new secret, app hosting just creates a new version of the specified secret. Then, to view all the versions of the Google API key secret, you can use the app hosting secrets describe command. In apphosting.yaml, you can specify a specific secret version. By default, the latest version is used. Apphosting.yaml also holds regular environment variables, as in non-sensitive environment variables. For Next.js apps, .env files will also work with app hosting, but we recommend using apphosting.yaml for granular environment variable control with any framework. What do I mean by granular? Well, you can specify which processes have access to your environment variable by using this availability property. You can restrict an environment variable to be only available to the build environment or only available to the runtime environment. By default, it's available to both. For Next.js apps, you can also use the next_public_ prefix, the same way you would in your .env file, to make a variable accessible in the browser. Apphosting.yaml also holds your Cloud Run configuration, where you can customize things like CPU, memory, and concurrency to optimize your app's performance and costs. To improve the performance of Friendly Eats, let's ramp up the CPU to 2. And now it's time to deploy. For the purpose of this demo, I've already created an app hosting backend and connected it to this GitHub repo. So I'm all set to push to GitHub and watch the rollout go live. All right, our changes are live. Let's check out these restaurants. Wow, I'm loving these review summaries coming from the Gemini API. And what I love even more is that I can view this page before all the summaries are finished, thanks to app hosting streaming support. Now let's inspect the Cloud Run revision to confirm that the updated apphosting.yaml configuration was applied. Back in the app hosting dashboard, click on the 3 dots for the most recent rollout and select View Cloud Run Revision. Sure enough, the CPU limit is now 2, and we can even see the reference to the secret that was used by the Google API key environment variable. You can click on the secret to manage it in Cloud Secret Manager. But how do we know that bumping up the CPU limit had the desired effect on our app's performance? You can access your Cloud Run traffic and utilization metrics from the app hosting UI in the Firebase console. According to these charts, our app's CPU utilization dropped after we deployed the updated run config. Our plan seems to be working. All right, let's recap everything we just did. We created a secret for our Google API key using the Firebase CLI and Cloud Secret Manager. App Hosting automatically added that secret binding to apphosting.yaml to make it available to our backend. We also looked at secret versioning and granular environment variable management in apphosting.yaml. To improve our app's performance, we increased CPU to 2 in apphosting.yaml. Then we rolled our changes out to production with a simple git push. App Hosting automatically generated static assets in Cloud Build, deployed dynamic content to Cloud Run with our new Cloud Run configuration, and served static content on Cloud CDN. Lastly, we used streaming to improve our app's initial load time. Enterprise-grade secrets management, granular environment configurations, and runtime customizations are just a few of the ways we're making Firebase App Hosting a solution that scales with you as your business grows. As we graduate this product from early preview to GA, we'll continue investing in enabling robust customizations of your app hosting backend. Now, it's my honor to hand off the stage to Mark from the Angular team. Angular and Firebase have been teaming up to build a great holistic web development experience with Google. Let's explore the latest from Angular with Mark.
Thanks, Julia. I'm overjoyed to share more about how the Angular team and Firebase team have been working together to make app hosting the best place to host your Angular apps and serve your customers at scale. We've been collaborating, adding updates to Angular and Firebase to build a seamless deployment experience with the platform. Developers can take advantage of powerful Angular features like Angular signals, template-level lazy loading with the new defer syntax, as well as Angular support for server-side rendering and hydration. And there are even more available features providing developers with the tools they need to build scalable web applications. Remember when I said that the two teams have been working together? That's good because we've been able to create something fantastic that will surely benefit developers. Automatic build and infrastructure orchestration for your web apps. This isn't the only part of the Angular and Firebase story that I have updates on. We know that developers rely on Angular Fire to build immersive, real-time applications, but we also know that there were some opportunities for us to improve the developer experience. I'm happy to announce that Angular Fire is on the path to GA, and we're bringing new, more robust documentation and examples along with it. Julia showed us how to deploy a full-stack Next application, and we can use app hosting to deploy full-stack Angular apps. I'm going to take us through deploying a full-stack application that leverages the latest server-side rendering and hydration features from Angular while also using the Gemini API. This is Friendly Chat, using the latest version of Angular. Before we can deploy it, we need to make a few changes. First, let's make this a full-stack application that supports server-side rendering. From the command line, I'll type ng-add at Angular/SSR. The Angular CLI will complete all of the scaffolding for me. One neat feature we added is the ability to ask our friend Sparky from Firebase questions during the chat using the @Sparky syntax in the message. Now, Sparky gets their smarts from the Gemini API. Since this application uses the Gemini API and there's an API key that I don't want to make public, I'll create a secret using the Firebase CLI and configure it in my application. We'll use the same Cloud Secrets Manager integration in Firebase App Hosting that Julia used in her example. With the API key set up, SSR enabled, and my GitHub repository already connected to my project in the Firebase console beforehand, all that's left is to push my changes to GitHub and let App Hosting do the rest. From my project, I commit my changes and push them to the remote repository. And just like that, my app is deployed to the web. This is cool, but I think we can take this demo a little further. The app features a profile page for Sparky, and Sparky's profile page won't change often. This means that this page can be pre-rendered on the server and just served as a static page. I just need to update the configuration a bit. In Angular.json, I need to update the builder options. First, adding the pre-render object, then adding the discover routes property with a value of true. Oh, wait. What if the data used to generate these pages gets updated and the pages need to be re-rendered? Here's a great example. There's a typo in Sparky's bio. I can update the data in Firestore, but that means that Sparky's profile page in Friendly Chat is now outdated and needs an update. The source code hasn't changed, but the data used to generate this site has. That's no problem. App Hosting supports the ability to manually force regeneration of static content by triggering a new rollout from the Firebase console. In the Firebase console, we can redeploy the latest commit, which will trigger a regeneration of those static pages. We can go back to the application and find the updated static files being served to the web browser. Hey, that was smooth. I like this new feature, and I think you're going to be able to do some great things for your customers and users. The Angular team will continue to work with the Firebase team to make app hosting the best solution for hosting your server-side rendered Angular applications. It's ready to meet demands of your customers at any scale. All right, that's all for me. Let's head back over to Thomas.
And what talk would be complete without a few surprises at the end? In addition to all the foundational changes we've made with Firebase App Hosting, we've added a few highly requested features. By building a new domains management system from the ground up, we were able to offer wildcard subdomain support on day one. You can now build multi-tenant applications that scale to hundreds of thousands of tenants with a single Firebase App Hosting backend. And our new networking infrastructure has allowed us to redesign Firebase App Hosting to support streaming. This improves time to first byte and better supports generative AI in your applications. And that's our early preview of Firebase App Hosting. It's the new home for full-stack Next.js and Angular apps, designed to bring Firebase's ease of use to large-scale applications. It was built with our founding principles of full-stack first, framework-aware build process, Git-centric workflows, and modern architecture. This early preview of app hosting is just the first step in a very long journey. We have a massive roadmap that could keep us busy for years. To help us prioritize this roadmap, visit firebase.uservoice.com to vote on the features that matter to you most. Expect to see static file optimizations with global replication, many more regions supported, preview versions of your application, and more sample apps, just to name a few. We have so much to do, and we want your input on what matters most to you. To get started, download the Firebase CLI or visit the Firebase console at console.firebase.google.com. You can explore Firebase App Hosting with our updated collabs, one of our dedicated sample apps, or a third-party sample app written for Angular or Next.js. On behalf of Julia, Mark, and myself, thank you for watching. We look forward to seeing the creative web apps you build with Google.